we observe here, so in yesterday's class, we have been studied that the soaps are not give good results with hard water or a tube well or hand pump water. So because hard water contains what, guys? Hard water contains salts of bicarbonates, or maybe they contains the, what is that, everybody? Sulfates and chlorides of calcium and magnesium. Is it right, everyone? So they contains sulfates, SO4, and chlorides, Cl2, of calcium and magnesium. So that is why they will react with the soap and they will form the scum-like substance. So instead of forming the foam or lather, they will form the scum. So that is why soaps are not give better results with the hard water. So that is the reason to overcome that, to get a better results with the hard water. So we are having a what, guys? So we need to go with the what, everybody? Yes, please. We have to go with the detergents. So these detergents will help us. They will give you the better results and they will make us to clean the surfaces better when it is, even though we are dealing with the hard water. So that is what we have been made it. So now let us come to the activity 4.12. So this is also one of the most important activity. So again, the same thing. So now take 2 test tubes with about 10 ml of hard water in each. So yesterday we have taken, one is normal water, one is hard water. Am I right or wrong, everybody? Yes or no, guys? So now today's you have to take both are hard water only. So take 2 test tubes, everybody. Draw it aside. So take 2 test tubes. So one test tube A and another test tube B. And both the test tubes you have to add how many ml of water? Yes, please. How many ml of water? You have to add 10 ml of water. Okay. So now 10 ml of water, if you add it, so then what else next they are saying? Add 5 drops of soap solution to one and 5 drops of detergent solution to the other. So that is what is we have to do it. So add 5 ml of soap and here 5 ml of soap solution and here 5 ml of detergent. Okay, detergent solution. Okay, so now you can tell me what is the conclusions they are asking. Detergent. So now shake both the test tubes for the same period of time. Do both test tubes have the same amount of foam? In which test tube a curd is solid formed? So everybody make it fast and tell me. So I have taken test tube A and test tube B. Test tube B I added 5 ml of soap solution and test tube B I added 5 ml of detergent solution. So in which test tube we will get? Both test tubes do not have, they have an equal amount of lather or different? Everybody. Do both test tubes have the same amount of foam or lather? Everybody? Please respond. What is your observation? You can tell. Is it, does both test tubes have same amount of foam? That is what is my question. Is there anybody in meeting or all are sleeping? So both we have taken a hard water and we are adding, one is soap solution and another one is a detergent solution. So definitely we know that in hard water, who will give the better result? Everybody? Who will give the better result?
Detergent.
Detergent will give the better results. So here we'll notice the greater foam compared to the here. So in which test tube will notice it? Do both test tubes have the same amount of foam? No. They do not have equal amount of lather or foam because detergent can go with a better reaction with the hard water. Next, in which test tube is a curd is solid formed? Curd is solid, call it as something. What is a curd is solid we used to call? Curd is solid, call it as something. That is only hard, that precipitate we used to call it as. What is to call? A scum will form. So scum will form in which one? That is what soap solution. That is what test tube A. So test tube A will get a scum solution. That is what we used to say a precipitate. A precipitate will form. So a lather actually, if you notice it, so precipitate, no lather is formed there, but in test tube containing detergent, so it will form a completely a foam, foam or a lather. You can see precipitate does not form at all in the test tube. But if you take, it will form a precipitate, no lather at all here. So it will be completely form a precipitate. So very less lather, or we can say even no lather or a foam, it will be formed by the test tube A. So that is what is the conclusion. So you can see that detergents can be good cleansing agent even in hard water by giving a good amount of lather. That is what you have to remember. So write the statement. So all of you remember detergents, write it. Detergents are good and stronger cleansing agents. Detergents are good and stronger cleansing agents as compared to soaps. As compared to soaps. As compared to soaps. And they are required in even a small quantity. They are required in 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 a small quantity. Clear, everybody? Yes, please. All of you. Next. That is what you have to remember. Advantages. Then second you write. Detergents can show good cleansing action. Oh, that is over. Okay, right. Next. Good cleansing action. Action even in hard water. Even in hard water. Even in hard water. Which consists of salts of calcium and magnesium. Consist of salts and calcium and magnesium. Next, third point. Detergents are highly soluble in water. Detergents are highly soluble in water. So they can form micelles easily. They can form micelles easily. Means the cleaning reaction is very faster. Next. Synthetic detergents can be used in acidic water. Synthetic detergents can be used in acidic water where soaps cannot be used. Synthetic detergents can be used in acidic water where soaps cannot be used. Are you clear, everybody? Soaps cannot be used. So that is the advantages of what, everybody? All of you? Yeah. So they are the advantages of detergents over the soaps. But what is the disadvantage, sir? So if you take the disadvantage of a detergents, so very few are there. So let us see that now. So if you have taken the detergents, so of course, if you have taken the soaps, first let us discuss. Soaps are manufacturing with what, guys? Fats of what? Animals or plants. Am I right or wrong? All of you? So that they are degradable or biodegradable, everybody? Sorry, biodegradable or non-biodegradable? They are all biodegradable. Am I right or wrong? So that they can easily dissolve with what we can say is they are all biodegradable. So they do not have any kind of harmful action with nature. But if you have been taken these disadvantages of these detergents, they are manufacturing with basically synthetic detergents there. So we are using non-biodegradable substances. That is what petrochemicals. So we are using a petrochemicals for manufacturing the detergents. So what will happen means they are what actually non-biodegradable. So no bacterial, no kind of microorganisms, or we can say microorganisms, something we used to call it as, who will eat? What we used to call? All of you? Our environment also started. Yes, decomposers. So no bacterial decomposers will take action on detergents. So it will leads to water pollution. So that is the major problem. What we have a disadvantage with the detergents, what we are using. Decomposers cannot be take anything. And also remember, these detergents, they contains phosphates actually. So phosphates, which actually allows, they contains, right, they contains some phosphates. So actually they will encourage the growth of some weeds. That is the major problem. If you give to the land, so they will encourage, okay, unnecessary plants. So unnecessary plants means, what is the unnecessary plants? We used to call it as encourage growth of unnecessary plants. That is only we used to call it as a what? Everybody? Weeds. Clear, all of you? And main thing, once they will go into the soil pollution also will take place. So this is the disadvantages of detergents over the what? The soaps. But if you take the soaps are decomposed by the bacterial action. Decomposers can be, because they are saturated fats. They are the fats of carboxylic, long chain carboxylic acids of animals and plants. So they can be easily. But it is detergents, this is the disadvantage for us. That is why, so we are always facing a difficulties with the detergents. So there is some disadvantages, which is a major effect on our society. So understanding means our nature, our land is polluting, our water is polluting majorly because of this. That is why you can see the industrial areas, like majorly from this Uttar Pradesh and all, you can see that Yamuna River, that and all, this is full of foam. Foam is forming, and you can see it is extremely polluted. There is a question in our question paper also. You might be seeing the previous year's question papers and all. So ladies are standing in the Yamuna River. There is a case study question for you. Do you remember, everybody? I think those who have got through the, you can see that future, you can see, will practice in time, you'll get it. So they are asking what it contains. Yeah. You can see here, in this case also, all of you, the polluting water, where we are noticing the more foam and all, it's to, this is what is actually the phosphates contains, or this detergents are too much of using. This skin industries and all, where the animal skin will be treated, they will use extremely high amount of detergents and acids, so that directly they will dump into the water, so it will lead to major pollution. So this is all about the detergent story and as well as soap story. Now there is a concept in our book, so please go through that and learn 1 hour. Of course, tomorrow you have an exam. We will study. Anyhow, next week only slot 3. There is a gap also. So we'll prepare for that. So now there is a concept, call it as a vital force theory here. So that I want to discuss it now. So if you all open it, then we'll go through that. So the vital force theory will says that this is nothing is the big theory. So initially it was considered that, all of you remember at the beginning, like organic compounds. So basically compounds which are constituent of carbon and hydrogen, we used to call it as a organic compounds, or simply we can say hydrocarbons, basically. So if you notice at the beginning, the people used to consider that those compounds which are derived from living organisms, means whatever the compounds you are getting, either it is coming from animals and plants, they are actually the organic compounds, and these cannot be synthesized in the laboratory. So that is what we used to call it as a vital force theory. So you might be having, where is that word here? Yeah, vital force was, it is necessary for the synthesis. So that by that time people used to believe that, so whatever the compound you prepare, definitely it is coming from the animals or the plants. So they must have a base. So it is not possible to prepare in the laboratory. So that is the theory which we used to call it as a vital force theory. But later you can see what this theory will say is that organic compounds are not possible in laboratory. The preparation of organic compounds is not possible in laboratory. That is what we used to call it as vital force theory. So later, Mr. Friedrich Wöhler, you might be see his name also here. So Friedrich Wöhler disproved that in 1828 by preparing urea from ammonia cyanate. So not from the plants and all. So directly he converted ammonia, NH4, CNO. I have given you that equations also. He just heated rearrangement. It has been turned up into urea. So after preparing this, then only they understand that no, we don't need any kind of animal or plants to prepare the organic compounds. We can prepare the organic compounds even more easier in laboratory. So that is what is all about the vital force theory. Mr. Nimish, are you clear? Anything doubt, you can ask me. So now, my sincere suggestion. So as I left the concepts of allotropes of carbon, that is what diamond and graphite and as well as fullerenes. So the fullerenes example is C60, Buckminster fullerene. So use this paragraph also, kindly go through that and learn it. Everything is necessary to study. So now the concept which we'll never discuss about this in this entire book, but there is a concept in the first question itself, that is what number of bonds. You can open the exercise. That is the most important question. The written notes, handwritten notes, what I have given, there you will be having the number of bonds calculating. So in exam, they might be asked number of CC bonds, number of CH bonds, or simply they will ask you covalent bonds. So all are covalent bonds only. Particularly they ask CC bonds, you have to say CC. If it is a CH, you have to say CH. So that is what it is. Now ethane with the molecular formula C2H6 has, they're asking C2H6. So you can draw. How many? C2H6 means ethane. So how many bonds are there? So of course here a simple compound they have given, but definitely exam you'll be having a little common name. Even they have given here direct formula. You know, board exam, many years they asked this question, but you remember, they will never give you the formula and they will never give you the IUPAC name. You might be all knows. Yesterday's one question also they asked. I have taught you. They ask you the common name and IUPAC names. So please kindly spend time, learn all the common names and IUPAC names. Definitely you are going to be step forward compared to others. So what is the number of bonds? You can see is that 1. They are asking simply covalent bonds. So no specifically. 2, 3, 4, 5, 6, 7. So answer is 7 covalent bonds. So this concept, nowhere book they will discuss. Only they will ask in the exam. You have to go through that and you have to learn it. I have written in my notes all the concepts I have written. You might be notice it. Most of the cases I have calculated that. Am I right, everybody? Those who have gone through that, you can find it on. Clear, everyone? So please go through that and spend time for it. And that's what is my expectation also. So everybody need to learn everything, whatever I have written. Definitely you are going to face it in the exams. Any exam, you are going to face it. The questions, what is given. Hari, I have given you one question. I told you to find it. Have you found that question? Yes, Hari?
No, sir.
Yeah, previous years, additional papers are normal papers. If you see that, you will find that question. If my guess is true, last year additional paper, you go through one, sorry. Definitely you can see it. Okay. So the question what I told
Okay, sir.
yesterday is, you all can see that. So that is the question. Actually, it is very important. The question number 37, I think. So here the question is, you can see all of you. This is the question we need it. Name the chemical reactions. Sorry, here, yeah. From here to here, identify the compounds formed in this step A and replace it with its next homologous. So like these questions is very, very important for big, long answer questions. So definitely they will ask you in the board exam also. So they will give, in the explanation, they will give some compound, but they will ask you the reaction with the next homologous compound. So by that time, unless you know the next compound how to forms, so always remember, irrespective of alkanes or alkenes or alkynes, or it is a alcohols or aldehydes, or it is some other XYZ. So one homologous to next homologous, only what is varies? One carbon and how many hydrogens? 2 hydrogens. If you add that, then you will get the next one. So that is what is the only logic you have to remember, and you have to do it. And there is a question also, of course we have a time, we'll go through that and we'll find that question also. So last year also they asked like that question 1. So that questions, they will give an explanation one compound, but they'll ask the product with the next homologous series. So that is why we must have a clear idea about it.